All right, welcome to today's presentation of the DBA Fundamentals Virtual Group. Today we're going to have the function of windowing functions by one of the speakers that I am very familiar with, Kevin Wilkie. He is probably one of my favorites to hear from. Today, let's talk about DBA Fundamentals, the virtual group itself to start with before I hand it over to him. The group leaders are Steve Cantrell, Shane O'Neill, Warwick Rudd. Yes.
Sorry to interrupt. I'm helping the speaker get ready, but you're not displaying your screen.
Oh, I'm not.
Just so people can see that lovely discount code and all that stuff.
Can you see it now, Steve?
Yes, looks good now.
All right. All right. Thank you for that. All right. So with that, as I said, there are the four of us to actually present, are leaders of this group. Ways to get in touch with us are, as always, the DBA Fun website, the YouTube site for SQL Pass TV, which has everything for Pass. You can always reach out to us on Twitter at the DBA Fun. You can visit us on our Slack channel where there are lots of great lively conversations, or you can reach us on LinkedIn where we have also many different conversations. So there are many different ways you can get in touch with us. All right. With that, we go to our sponsors. DBWatch Database Control. They have a tool that is for their enterprise manager that has its complete solution for database administration, monitoring, performance tuning, and it works not only for SQL Server, it also works for Oracle, Postgres, and I believe a few others. I have not got to play with any of the others, but I do know it works for at least those. Please try it out. As you see, there is a free trial on dbwatch.com. There are many other blog sites as well you can view it on, see what you think about it, because you do get a free trial. It is a great product. Be sure to remember DBWatch if you're in need for something, for a one-site solution for everything, so you can monitor it, do whatnot. Also, our other big sponsor is SentryOne, that helps you build, test, document, and monitor SQL Server, the Azure SQL database, and the Microsoft Data Platform. They have many sites to view different articles, resources, tuning advice, as well as one of my favorites, the free trials, and one of my favorite tools of all time, the SentryOne Plan Explorer, which you can get on this website here. It is truly makes life easier when it comes to looking at Explorer plans and making life easier when you're doing performance tuning. So please make sure to visit both of our sponsors. They truly have great products, and we would not be here without them.
Kevin, one more thing. Sorry to interrupt.
No,
Shane,
you're good.
well, I'm sorry. The sound, before we get to the speaker, the sound has some static quality to it. Are you on a head?
I am. Let me switch out of that.
Is that the way you hear it, Shane?
Yeah, slightly staticky.
Yeah, okay. Now shut up. You'll probably get it fixed.
It could be just me, you never know. All right, let me work on that whenever I give that over to the speaker, or at least try to do it. All right, so with that, hopefully everyone is aware that Pass Summit is going virtual this year. Please be sure to go to that the website not website, the actual summit itself to make sure that you can see everything that goes along with past summit. It behooves you obviously to get onto past summit because you can learn lots of things and network in different ways. Obviously, virtually networking this year. With many learning opportunities, you'll learn a lot of things in a very condensed amount of time. So with that, we do have our own discount code this year to receive $50 off of the past 3-day registration. Be sure to, when you sign up for it, if you haven't already, go to this website and use our discount code VGDISM843. It helps us as well as you to receive all $50 off of the registration. So with that, let's go to our speaker. Our speaker is Kevin Wilkie. He has been working with SQL Server for over 15 years now and has done a lot of work with SQL Server, obviously. All right. Let me stop there. And now we go to this one. All right.
I knew we'd have trouble swapping with this speaker.
You know. So, as Kevin said earlier, I am going to present today on the function of windowing functions. As I said, I am the presenter. As some of you may have caught, I actually am also one of the co-organizers of the DBA Fundamentals Virtual Group. So I get to do things like this and present on one of my favorite functions of SQL Server itself, which is the windowing functions. I've done several things over the years. I actually now am more closer to 20 years of experience with SQL Server. So with that, let's jump right into windowing functions. So many of you asking, what actually are windowing functions? You've heard about them, you want to try to use them, but what are they? First off, it has nothing to do with the operating system. I'll bring that up only because when I first started messing with windowing functions years ago and talking about them, I actually was asked by one of my business people, what's it got to do with Windows 10? Well, at that time it was Windows 7. I'm like, nothing, absolutely nothing. All a windowing function is a function performed over a range or a window of results. It's been available since SQL Server 2005. Most people didn't really use them back then. With each successive version of SQL Server, we've gotten where we use more. You should be using them more and more. But starting with SQL Server 2005, we got a grand total of 4 windowing functions to work with. They are as listed here: row number, rank, bench rank, end tile. That's it. First off, you wouldn't think there'd be too much you could do with those, but you would be very, very wrong. So let's go to a demo. So first off, I'm going to be doing everything in the AdventureWorks 2014 database, just so you can see and get familiar with some of these functions that we've used over time. All right.
Kevin,
So
you may know this already. You may know this already, but You're not showing a demo screen. You're showing your, and that may be what you're trying to do now. I don't know. Just want to let you know.
I should be showing. All right, now can you see SSMS?
Yes, that's what you got. That's the example.
Cool. All right. So, as I said, using VentureWorks 2014, you should be seeing a lot. Let's see. When we start working with windowing functions, we deal with probably the most simplest we'll play with is row number. So let's go over what a windowing function truly looks like. Most of this we should be familiar with. Select a couple of fields from a table. Then we go into the new thing for just windowing functions themselves, row underscore number, and then we have open and close parentheses. That's just one of the ways that we can tell it's a function. But the over here is what truly we can tell that it is a windowing functions, because all windowing functions themselves have the over keyword in it, period. That's the easiest way to tell. Then we have this block here. For almost all of them, you will have some kind of something inside of parentheses after the over, so it's tell it the window that we want to work with. In this case, I just gave it an order by just so we could see clearly and quickly how some of this stuff works. I like to give it a name, an alias, just so that I can work with it a little easier when I'm dealing with other items. So when we run this, as you see here, I get sales orders, I get customers, and I just ran this by order by customer ID. So there's however many, 31,465, and if I scroll to the bottom of the list, you'll see I have 31,465. So I'm truly showing how many rows there are for this, for the entire group here. But now, if I want to do something a little different with this one to give it a little bit more functionality, I've changed this one a little bit so that I am partitioning it by an order date and then ordering it by customer ID. So if I run this one, you see I get a little something different here. First off, it's all ordered by the order date. So I truly don't have to put in order by the order date and whatnot. It comes up automatically where it'll show by the order date. But then I go through here and I got row numbers that look like normal so far, or it's ordered by the customer ID. 1, 2, 3, 4, 5. Keep scrolling down. Oh, look here. After we change from 531 to 6-1, it starts over. The row numbering does. So we have brand new set where it's truly a partitioned off whenever we change the dates. If you scroll through here, you'll see a number that are 6-1, 6-2, 6-3, and each time it starts over. And we'll do things like that when we're doing this partition, but that's where it can get a lot of help in showing some of this data to us. So here's the one I like to show off. This one actually shows, this query shows the difference between row number, rank, dense rank, and entile. So as you see here, when you're just looking at this data, there's not any true difference when you're just looking at them. You got a row number, you've seen that before. Rank looks pretty much the same. The only difference is the function you call. Dense rank is the same way. Entile looks a little different, but we'll get into that here when we're looking at the results. You'll see why it's done a little differently. All right, so I'm looking at one specific customer. I got the row number we're used to, our 17 rows, and there's 17 row numbers for each one. Rank and dense rank look pretty much the same until you get down to row 14 and 15 here. They're both done on the same day, so ordering it by since we're ordering all of them by the same thing, then these two come out looking exactly the same. It's when we go to the next line that something is different. Because for rank, it skips over that number and goes to the next. So in this case, it texts there are two that have the value of 14. We skip over 15 and we go right to 16. But for dense rank, we don't do any skips. We go straight to 15. So if there had been 3 of them, let's say these 3 with all the same value of 13, then for rank, this one would have 16 as it does here. Dense rank, on the other hand, if these 3 were 13, then this one would have a value of 14. The only difference is truly the skips or lack of skips for dense rank. And the end tile. End tile takes a number of buckets, in this case, 5, which is always provided here in the parentheses. You take these buckets or bins, whichever way you prefer to look at it, and divide all of the rows into that number. The number of bins into the number of rows, and give an equal number out to each one. So in this case, you've got 4 that have the first bin, 4 that have the second bin, 3 that have third bin, 3 the fourth bin, and 3 the fifth bin. So with that, do we have any questions? No. All right. So let's go back to our presentation. All right. All right, so the next one, after our initial set of 4, is called aggregate functions. These are functions that use aggregation without having to use group by. So many of us were taught that when we did aggregation, we had to use group by. That's incorrect when it comes to windowing functions, at least as of SQL Server 2005. At that point, you could start to using these nice functions without group bys, if you know how it works. These aggregations can calculate over a window or a partition, looking at the entire result set or a single partition. To show that, I have, as you'd probably expect, another demo. All right, so go back to this one. All right, so we all know how to do normal summations. We get to do, because in this case, we're just going to do select sum of the total due from a table, group by this, order by, customer ID. We're all used to that. We've done this 1,000 times. In this case, there's 19,000 different answers to this one. We're used to this. We're total ID, customer ID, total due. And then we're going to do sum of total due over, since it's an open parentheses, open and close parentheses, there's truly, since it's a sum, there's no point in having a order by. You could do partition by, but no order by. And then we just give an alias from the table. In this, we're going to do an order by, no group by at all. Give it just a second here. In this case, we get the entire cell that becomes, it's not broken down by the client ID, it's not broken down by sales order ID, it's just total sales. I have actually used the functionality for when I'm doing a SSRS report, or now a Power BI report showing everything that a client would have. I don't have to do anything funky with the queries to grab the value into a variable, push it here, push it there. I can do it all in one shot, and I just use a simple function that doesn't have to have a group by that we all get tired of typing all the group by items. Especially in this case, that would be horrible.
Yeah. Sorry to interrupt you, but your sound is still a little staticky, and it's going out every once in a while now. So I don't know if it's the way you're moving or something like that. Because this is good stuff. I want to get it. I don't want to miss it.
Let me see here. All right, does that work better there, Steve?
A lot better, a lot better. I think people will be happier.
Okay. All right. Sorry about that. All right, so we're now used to seeing all this data without the group by, just one sum over the entire thing, or we can do it by a partition. Between these two is the sum total due over and then given a partition by customer ID. So now we can see, if we look at just these three rows, we have our customer ID and the order date for them, as well as the total sales that we have ever had for this one client. Hopefully everyone sees the ways they can use that to make this much easier for themselves without having to do the group by that we've all gotten used to. All right, so with that, we go to our next little thing. As always. All right. Let's show this. All right. Yes. Okay. Now, when we do with 2012, and we started doing windowing functions, because we got good in 2005. We got those 4 windowing functions we've all come to know. We've got pretty good at them. 2008 R2, SQL Server had some issues it had to address. No new functionality for windowing functions. But when it came to 2012, they're like, ooh, I got things to add. I got things that people need to know and need to work with. So they added some new windowing functions. Did the accumulation aggregates, which allows framing. And we're going to obviously do more demos. Hopefully everyone's figured out this is a very demo heavy presentation that I love to give. All right, so with that, we've allowed framing. Let's see, I need this window. Let's do framing. So when we talk about framing, the easy way to, at least for me to think about it, is, for example, with running totals. So we're used to, now we've gotten good with the sums, we've gotten figured out how to do the aggregations for it. We're going to do sum of the total due over partition by customer, order by order date. This is one of those places where order by does make a difference in the function, in the windowing function itself, because as you see here, let's just take these 3 rows because they give a pretty good example of what we're trying to do here. We have the total due for this person for the customer on 6/21/2011, 37.56. Yep, that's all running total is. 620, 2 years later, they bought $2,587 worth of stuff from us. Well, their customer running total has jumped up. So this is a case where the order by does make a difference in the partition for our group, for this group. And it can help us as we're doing, obviously, our running total. When they come around 4 months later, they bought more stuff, our customer running total got bigger. Now, what if we want to do reverse rolling total? This one gets a little harder because, so let's back up a second. When we're doing the regular rolling total, what we're truly doing is this row, where it's the sum of total due over partitioned by, we're used to that. Now we want to do something a little different. We want to do rows between unbounded preceding, which means everything from the very start, where you're still in that partition, down to the current row. And as you notice, there is spaces. It's not underscore, it's not brackets of anything. It's just there's space between these words. That's how you get a running total. If you want to do a reverse total, you have to do same thing as you would do for the running total, but it's the rows between the current row and unbounded following. So it's a little different. The words are a little vague, but they do work pretty well once you get used to it. As you see here, let's go through our example of customer, 11,000. Total due is still the same. Reverse total, so we take it from the very start. This is how much at the very end, at how much they have done total, and then we just start subtracting that for each of these values to get down to the very last one. So it's the reverse of the running total. I just like to show the example of rolling total versus reverse rolling total to make sure everyone understands how, especially these functions right here are a little different, how you have to frame it, but you do get used to it after a little bit. You just have to work with it a lot. All right, so now we're going to do rolling average. So here I have our normal data, and I'm going to show what we have in the CTE here. Oh, I put too much in that. All right. So we have, this is not looking at, we have our order dates. We have everything that is for this order dates, how many were ordered, period. All right. And that's all the data that we're going to use within this query. So because you can see here about orders, and our CTE called orders. All right, so now we're going to take this data, we're going to take the order date, we're going to take the order to see, in this case, we're going to take 10 rows above it and 10 rows below it. We're going to see what the average order quantity sold for that day was. And that's just within a very specific window, not overall for everything within that's ever been sold, but it's only for a rolling 10 days. Well, in this case, rolling 21 days, because it's 10 back, as you see here, rows between 10 preceding and 10 following. So 10 above and 10 below. So when I run this query, take a second here. As you see on our day number 1, 5/31/2011, there were 825 orders. So our moving average only takes into account 10 below this row and 10 below it. So these rows, as you see here, these rows are the quantity ordered this day on each of these days is rather small. So we're average it goes down as we go along through here, 78 to 50 to 40. Then that we get down to row 12. That takes out row number 1, which is row high, and it only has down to row, in this case, let's see. This case, we have down to row 22. So we have these. And then, so you'll average all of those up. And so we have an average, very small average for these rows. So I have taken, in this case, it just takes the small average, bumps it up, and figures it out. So in this case, we have a, as you see here, it starts at 11, but our moving average or rolling average has jumped up considerably. So that means down here, in this case, 10 after row 22, it's rather high. So you can see things like that. And this can be used a lot for sales. That's where I've used things like this. I don't have to leave it at 10 preceding or 10 below. I can change this to be any number I feel like. So let's say I want to do 7 preceding and 3 following. I can run that as well. The average is going to be a little funky, as seen here, but you can do it. It's just whatever your client or business wants. All right. So I'm checking it. Are there any other questions?
No, you are good so far, Kevin.
All right. Thank you. All right. So we're now going back to our main presentation. All right. Okay, so SQL 2012 brought 8 new windowing functions, and thankfully they grouped it as well as they could. They are the offset group, which is lag, lead, first value, and last value. I'll give a very small definition here of what they are. There's also another group, the distribution group, which has these 4 items, which will go. You'll need to see demonstrations of each of those to see truly how you can work with each of them. I'll give it, obviously, as you've seen from here before, we have lots of demos. So with that, let's go to the demo. All right. So first, let's work with the offset functions. As you see here, I'm using lag and lead. That's the ones I like to show off first. That's one you'll use primarily of these offsets. At least in my case, that's what I've been using. So lag just means a previous row data. And what you'll notice here is with lag and with lead both, I can only specify one field. So I can only grab one field's worth of data from a previous row. I'm ordering it. I'm doing my normal windowing function. So I have an over, partitioned by customer ID and order by sales order ID. I'm doing the same thing for lead, same exact phrasing, same exact look. We're going to order it by the customer ID and the sales order ID. So let's look at our favorite customer here, 11,000. Same 3 orders. So for the first sales order, there is no previous sales order. We truly are at the first, so there can't be a last sales order ID. But we do have a next. And as you can see, that corresponds with this number down here. When I get to this sales order, we have a last or a previous, because that's 43793, which you see here. And we have a next, 57418, which is here. And that's how this works. Basically, just figuring out last time that we saw this value, it gets a whatever that sales order ID, since that is the value we looked at here. Things like that. That's how the lag and lead both work. Let's do something a little bit more fun here. You can work with days in this. It's a little bit more fun to play with. In this case, what I've done is days since and until. So it's the last time they got an order from us versus the next time that they get an order from us. You see, it's all I did was the date used the date diff, and then I did it by days. I used the lag function in this case to grab whenever the next one was. Then I compared it to that order date right there. So I did the same thing for lead. I just did a date difference. And I took those days. So I compared these two for this number, and I got 730. And thankfully, these two will be the same for all cases, especially since I've made sure that they have the same stuff here. So we're comparing 105 to 105, and thankfully, since there is no next order from them, you don't get anything for this person, for this client. All right, so with the lag and the lead, you also get an offset, a special offset parameter or a special default parameter you can use. So no longer do I have to see the nasty nulls. If my business says I don't want to see nulls, I can make it happen. Or I can make it to where I'm doing it not just by the last one or the next one. I can do 2 or 3 back. I can do 7 back, whatever number I want to come up with. So I run it the same way. If I want to do, as you'll see here, when I run, just look at my favorite customer again. On 621, obviously it didn't have any 2 order. Go back 2 orders. You can't do that because for these 2, there is no previous 2 orders. So the only one that actually has a value is this date. And that you just see where it was 2 previous. In this case, I can go forward 2 orders as well. That doesn't show very well for these clients that only have 3 orders. You go down here, there are some like this one where they have multiple orders. I get lots of values for this person, for this customer, and I get very few that have my default of 112,000. As you see, it's on both sides. Now, I know you're asking yourself, what if I just want to have the default? I want it to do the next time, the previous time. Well, as we all know, you can't do this. It will come back and say, nope, can't do that. Because it's confused. Trying to convert a varchar to a big int. Nope, ain't gonna happen. So what you do, you just tell it 1, make it simple. And it will show that right up there, no problem. So as you see, it just did 1. Now, what if I want to do I want to tell it just 2, and I don't need the default? You can do that just like this. Pretty simple offsets. We're all used to doing with optional parameters. All right. Now let's go to first value and last value. So let's run first value here. This one's fairly simple. All right, so customer ID 11,000. First time that this person ordered was 621, and we can verify that 621 2011. Yep, good. All right, first value works great. So let's see last value. We run the same thing as you see here. It takes last value, looks exactly the same as this last one. We run last value. Takes a second here. Look at it. It didn't quite work. We have 621 is the last order date, but it's not because we got 620 and it's getting confused. The first time you run this, you'll think, oh, I must have done something wrong. Not really. You just forgot, because as I said previously, you have to use the frame. That's why we had to have that. So when you add this frame, the rows between current row and unbounded following, that's when you get the correct last order date. It doesn't know this by default. It truly thinks that you're only looking for that row in previous. So since we ordered it by the sales order ID, or we can order it by the order date, either way, if they are the same in this example, then you would think it would take by that default, but no, it truly thinks it's just looking at everything previous to there. So that's why you truly have to remember to add the rows between current row and unbounded following. And truly, every time I use last value, I always run it and I come across this and I'm like, dang it, why did I not remember that from last time? And then the next time I use it, I make the same mistake every time. Hopefully you'll do better than me, and you can remember that last value truly needs this row here to get more than what you think it will show up. That's why I bring it up, just to make sure you're better than me. All right. So, and that's why I bring that up, just so you remember last value, first value. First value, you don't have to do anything by default. Last value works. If you have it ordered by, this is how it should work. Yeah. All right. So now we've gone through the offset functions and they work pretty well. We're getting all good on that. Now we're going to the distribution functions. Those can be fun because, as you see here, I've on my demo here, when we run this value, and you'll see I've changed another thing for away from sales order IDs. We're going to look at the human resources schema to compare the department, the last name of the employee, the rates, and the distribution versus the percent rank of a group. And we're just going to order by department and rate. So let's kind of focus here. We got all of our different things, and there's a fair amount of data when you look at it. So let's just focus here on the engineering people. So the one that gets paid the most in our case is Duffy, 63.4615. His cumulative distribution is 1, and cumulative distribution and percent rank are both the same. Where they start looking different is when you get down from there, because you'll see there are 9 different groups that these people that you can be in. There are 9 people showing in this group. 63, 43, 36. Then 3 that have the same, 29, 23, and 8. Gotta feel bad for the guy who only makes $8 per hour. So with this group, they have, for a cumulative distribution, it takes it and divides it equally by each one and shows what group they're in. So the number here at the bottom is some number other than 0. But for percent rank, the bottom one is always going to be 0. That's how I try to remember the differences between these two. Sometimes you just have to play with it to see which order it comes out and which one shows you the data the way that it should be, or that you want to display it to your users. So yeah, that's how I remember it. This one is going to be, the bottom number is 0 for percent rank. Cumulative distribution is a number higher than 0. And then you just divide. And for percent rank, it's the number of rows minus 1 is what you divide it by, all your answers. And for cumulative distribution, it's the number of rows. And as you can play with this, you'll see more and more what that makes sense of. You look through this data, and as I'm sure y'all know by now, I'll give out all the presentation materials so you can work with us and look at it and hopefully make it make sense to you as you play with it, so you can see more data. All right, so now the big function that we like to show for our distribution functions that were provided between 2012. As you see here, I wrote out what both of these mean. The percentile continuous is just it shows the percentile based on the continuous distribution of the column value. So it's interpolated, and it might not be equal to anything that it shows on a string. Of percentile discrete distribution is based on a discrete distribution, and it returns the actual value. So all that to say, when we look at this, I've got them based out here. What I'm truly trying to show here is the median value for the entire group. And I'm just going to look at the human resources department. The median, when it's based on the percentile continuous, is the same for everyone. And as you'll notice, the median is not listed over here in any of these rates. But when we do it discretely, it does show one of the values. It has to equal an actual value. And if you want to, I don't want to have to go into statistics in here because it probably bores some of you. I know it rather bores me sometimes as well. But if you truly want to go into it, I found this website several years ago. It shows a great how this stuff works, and it shows an Excel spreadsheet that you can play with and see what some of these values are and how they would be resulting for you. So with that, go to our next screen. All right, so I'm actually going to do something a little different this time than I normally do. I'm actually going to go back to this one, and I'm going to show you what I consider useful functions for windowing functions. There are a lot, so bear with me. First thing that I try to do whenever I'm working with some of this stuff is really a first thing I like to do is just look to see. So, for example, on this one, I'm just going to look at person.address for the MetroWork 2014 database. Okay, and there's a lot of data in here. I don't know about y'all, but I do not want to go look through it. Here's the first one. What we've been asked to do is find the first row of each postal code for each table. So, for example, obviously the address ID for 9801 would first show up would be 1. Notice I don't have it ordered by, and so good luck trying to figure out some of the rest of these. If you can do it by hand, you can do it in Excel. You have to sort by this. First time it fills up, or first time it changes zip codes, you display it. You can do all kinds of things. SQL Server now, I get it much easier. So all I'm going to do, you see here, I've got my favorite windowing function. Select star from star and from person.address. We want to have the roll number windowing function over partitioned by postal code. So every time that, as you saw in my first demo, partitioned by the postal code, this will actually make it where it starts with 1. Next time I go to the next postal code, it starts again with 1. We want to order it by address ID. Now we got this, where row num equals 1. This is why I like to use the alias over here, so that I have truly something to look at. I see lots of people row num, RN, all kinds of things. Just so you're consistent, you're good. Now we want to do it. We want to order. We want to show all that where row num equals 1. We want to order it by the postal code and the address ID. We run that. We can quickly get down to 661 rows. We are now have it by the postal code. It starts here with the 01071. I know personally, if I'd had to go search through all 19,000 or however many there was of this, I would be searching for a while. I don't have to worry about that anymore. I just have to go, let's go command where row num equals 1, and I'm good to go. I have all of them. right there. And it took truly to write this out, especially once you get used to it, maybe a minute, 2 minutes. And you can see it's pretty quick. It's extremely quick because it took 1 second to go through 19,000. I use this a lot. I probably don't have too many days where I am not using the row number function. I do a lot of work with data warehouses, bringing data into them, or dropping or cleaning up duplicates. This one I use frequently, and I do mean frequently. Like I said, there are not too many days, at worst weeks, that I don't use this function. For row number 1. All right, so this is, next one I'm going to show you is one of my favorites to do, and I've used this one a lot. What if someone asked you, find all the gaps in this table? So you see here, the address ID is 1, starts out with 1. There's 19,614 rows. But when I get down here to address ID of the very bottom, it's 32,521. And I ordered it. It needs to be ordered. It doesn't need to be ordered by it. But I will, just in case someone's out there thinking, oh, he's baiting us up. You'll see there's last row is way far out past 19,614. So now we can go through and look through that. Now someone asks you, says, oh, I need to find those gaps. I want to know what the gaps are. I have to make an Excel document, create it, copy all the data over, look for it, and then I give where this number wasn't equal to 1 more than the row before it. You can do it. It's a pain. And when you get higher than, for old Excel spreadsheets, older than 65,535 rows, good luck. Now, I've had to deal with lots of those. Or with newer versions of Excel, it's over 1 million. And thankfully, SQL Server allows us to have way more than 1 million rows. So what would you do in this case? You'd have to do all kinds of fun stuff if it was truly like 15 million rows. Actually here, I'm taking the address ID. I'm using the lead function where I'm going looking over and then just ordering everything by the address ID and giving it to LS and XRN. I look to see, in this case, I'm doing the values of next RN. I'm doing again minus address ID as a difference. So truly, it would just, most of the time, it's just going to be 1 if it's the same, if it's continuing the group. If it's not, then difference is going to be not 1. So when I run that subquery where difference is not equal to 1, then I can see how big the gap is. So it'll show the first row for the gap and the last row of the gap. And that's all there are. Those 3 groups. This is the true gaps for everything, which good luck trying to figure that out when you're trying to do that by hand. And you see here, it's 10,000 is this group. There's a group of miss of 13, and then there's a group of 2,622 that are missing for whatever reason. And that's how you find those. I found this function a number of years ago, and it's greatly helped me when I'm doing any analysis on gaps. So with that, let's go back to my presentation. It's being mean to me again. Oh, here it is. All right, so I will show. All right, so if you've enjoyed this presentation, kind of some things that I've shown, then hopefully you'll like some of these books as well. I really recommend Aunt Kathy's book, Expert T-SQL Window Functions in SQL Server. She did this a few years ago between her and Clayton. They did great book. I use this a lot, especially when I first started out with SQL Server with using windowing functions. I also use Ben Gann's book, Microsoft SQL Server 2012, High Performance T-SQL Using Windowing Functions. It is very detailed, very in-depth. Make sure to keep you some aspirin by the side of your bed as you read this, because it's tough, but you will really enjoy it. You'll find out lots of new things you can do with window functions. Now, if you've truly enjoyed my presentation and want to see some things you can practice with, then you'll need to go to my website, surfloatdata.com, where I have put together this website to give you some examples that you can work with yourself and hopefully can learn and play with a lot more stuff as time goes on. If you have any questions, I'm always free and available. And that's the examples. There's a number of examples you can play with. You'll use all of the functions that I've shown, and you should be able to figure it out. If you don't, I'm available for any questions. So with that, you can obviously go to my website. You can hit me up on LinkedIn, Twitter, or you can just flat email. So with that, Shane, do we have any more questions?
There is a question which I think you've touched upon in your presentation. How does window functions perform based on millions of rows, like 5 million rows or so? And would you have any recommendations, like on, I say, tipping points of when to use Windows functions, when to not use window functions, or if there is even a tipping point?
The first four, the ones from 2008, roll number, rank, dense rank, and entile. There truly is no problem using those. I've done those with 50 million rows, and it comes back almost instantly. It'll be 3 or 4 seconds. It's really good for those. First value, last value, lag and lead. Those, on the other hand, they can take a little time, depending on how big your partitions and your data sets are. I tend not to go over 1 million with those, or try not to, just to battle down how fast the data will come back. What I usually end up doing is putting all the data into a temp table for those, and then running the whatever windowing function I need to behind that as a separate group, just because I don't want to have to deal with the slowness of the transaction for both of those. So that's what I tend to do. While I remember it, one of the things I've actually seen people do when they're doing my last demo is instead of using row number to get the first value, they use rank or dense rank. Please don't, because that actually does not work quite how you think it will. What happens is row number will always give you one value, but as you saw with rank and dense rank, it can give you multiple values back. So unless you want duplicates in your data point, you need to use row number. That's a big sticking point that I've seen many people use over the years. They keep trying to use rank or dense rank. Don't. It's always row number, because that is guaranteed to give you one value every time, where row rank and dense rank are not. I know that was a really rambling answer for both of you saying, but I think I answered both of them pretty well. And not remembering to talk about rank and bench rank because I've seen that so much.
Yeah, I think you covered the questions there. So, someone has a really kind of on the spot problem for you. Can you please show us gaps and islands example? If you have it handy, it would be great. If not, I'll leave that one up to you.
Well, I did show you my gaps. The islands is exactly the opposite, where it's truly not where it's equal to one. So instead of, let's see, get back to my example here. As you see here, this would be the gaps. It's truly what I had in my little demo. So the islands would be where it equals to one.
Sorry, Kevin, I can just see the final presentation slide at the moment.
Oh, it does. Damn it. One day I'll remember how to do that. All right, so. And yes. All right, so this one is the gap. So it's where it's not equal to one. That's the gap. And truly the islands would be where it's equal to one. Now I'd have to mess with this a little bit. Make it where it will show that cleaned up, and you can. Yeah, I'd have to change some of this. Yeah. I'd have to stop and think to see, because I've never had to do anything with islands myself. But yeah, that's basically how I do it. You can clean this up yourself.
Cool.
Does that help?
I think it helps me, and I think it'd be especially helpful. Like you pointed out, you've got the slides up on your shareproofdata.com. So I think that and playing around with what you have there would be great as well.
Yep, and I see a question came in. Are the sample queries available? They will be available as part of the slide here in the next several days on the DBA Fund website. And you can always go to my website, shareproofdata.com, to find my examples website, so you can play around with windowing functions yourselves. So
Perfect,
with that, if there are no more questions, I will end today's call. All right, sounds like it. All right, then I do thank everyone for showing. Y'all have a great day, and talk at y'all next time. Bye.